All right, calculus students, here comes another installment of the special topics. Although this is the 12th one that I've filmed this year, this might actually be your first one that you're watching. I'm basing this on the special topics packet that we gave out in spring of 2018. And I'm on page 1 where we're going to talk about limits, relative growth rates, and our friend LHospital. Okay. Now, specifically, I'm going to focus on the algebra involved in evaluating limits, and then we'll look at LHospital. With a lot of these special topics, I always do a couple of free response questions. We talk about the scoring rubric. That's not what we're going to do here. This is simply going to be brushing up on your algebraic manipulation skills involving limits, and we'll just go from there. So starting on page 1, I'm looking at example number 1. We're asked to find the limit as x approaches 2 of x squared minus 2x over x squared minus x minus 2. Now, usually when we're evaluating limits, one of the things that we try to do, it's called direct substitution. That basically is another way to say plug in. For some functions, the value of the limit is equal to the value of the function at x equals 2. In this case, x equals 2. But that's not always the case. So let's see what happens. I would get 2 squared minus 2 times 2 over 2 squared minus 2, which is 0 over 0. And we have a fancy name for this. This is not an answer. This is the indeterminate form. Indeterminate, indeterminate form. 0 over 0 isn't an answer. It doesn't mean that your limit is 0. It doesn't mean that your limit does not exist. It is nothing other than a signal that direct substitution doesn't work. I usually tell my students when we first learn about the indeterminate form, when they see 0 over 0, they say, uh-oh, get it? And that's a signal that you need to try some algebra. So let's go back to our initial limit problem, and what's some algebra that we could do here? Well, maybe what you think about is factoring in the numerator. I can factor out an x, which leaves me x minus 2. In the denominator, x squared minus x minus 2, that can be factored, or at least we can try. And if you factor successfully, you'll get x minus 2 times x plus 1. Now, where did this come from? That's an algebra skill. I'm not going to model that too much right now, but maybe you want to do like the trial and error method. Maybe you want to do the mama diamond or the Xbox, whatever it is. This guy is going to factor as x minus 2 times x plus 1. Another thing that we learned way back in the day when we dealt with limits is if you were getting 0 over 0, that normally meant there's a common factor in the numerator and denominator that you want to cancel out. So because I'm approaching 2 and I have a factor of x minus 2 in the in the numerator, I'm expecting an x minus 2 in the denominator. And that might actually help you with the factoring piece. Anyway, enough about that. You cancel out the common factors, and you get the limit as x approaches 2 of x over x plus 1. Now try the direct substitution, the plugging in, and you get 2 over 2 plus 1, which is 2/3. That 2/3 is your answer. That is the limit for this rational expression. Okay, not too bad. Let's move on. The limit as x approaches 0, 1 over x plus 3 minus 1/3 over x. Try direct substitution again. You'll get 1/3 minus 1/3 over 0, which is 0 over 0. That's your indeterminate form again. You want to go back whenever you see that indeterminate form. Remember, this is not your answer. Go back to the original problem. What else could you do? What algebra could you do to maybe change the way this problem looks? When I see the 1 over x plus 3 minus 1 over 3, what I'm thinking about doing is getting a common denominator. My common denominator has to have x plus 3 and 3 in, as factors. So to make this happen, I'm going to multiply the first fraction by 3 over 3. I'm going to multiply the second fraction by x plus 3 over x plus 3. And both of those are legal. 3 over 3 is 1. X plus 3 over x plus 3 is also 1. The reason that we're going to do this is that now you've got the limit as x approaches 0 of 3 over 3 times x plus 3 minus x plus 3 over 3 times x plus 3, and all that's being divided by x. You now have a common denominator, which allows you to combine these two fractions into one. 3 minus x plus 3, your 3's will cancel, and then you get negative x over 3 times x plus 3 divided by x. Now, before you do any direct substitution, what else could you do? Well, let's take the limit as x approaches 0. A fraction divided by x, or if you'd like x over 1, you can make this negative x over 3 times x plus 3. To divide by x is to also multiply by 1 over x, to multiply by the reciprocal. Now, why is that going to be helpful? Common factor of x in the numerator and denominator cancels out. You find the limit as x approaches 0 of negative 1 over 3 times x plus 3. Now try direct substitution. You get negative 1 over 3 times 0 plus 3, which is negative 1 over 9. That's your limit. Not bad. I would hope that both of these are going to be rather comfortable for you, that these would be high-scoring questions. I wouldn't necessarily expect questions like this to appear in the free response. More likely they'd show up as a multiple choice question, and I'd hope just about everybody gets those right. Okay, one more to really push your algebraic thinking here. The limit as x approaches 0, square root of x plus 4 minus 2 all over x. Again, try direct substitution. Square root of 0 plus 4 minus 2 over 0. No surprise here. 0 over 0, the indeterminate form again. Not an answer. This doesn't mean the limit doesn't exist. It means you've got to come back and you've got to try something else. Well, what's the something else? Way back in the day when we were doing this all the time, when we would see that radical, that was always a sign. What we would do is multiply by the conjugate. The conjugate is going to be this exact same expression, but instead of having a negative, you're going to have a positive. Square root of x plus 4 plus 2. Multiply in the numerator, multiply in the denominator. Whoops. And this is called the conjugate. C-O-N, whoops, J-U-G-A-T-E. Again, the conjugate is formed by changing the sign in between. And you might say, well, why would we do that? Well, when you do this, take the limit as x approaches 0. You're going to multiply the numerators together. The square root of x plus 4 times the square root of x plus 4 is just x plus 4. The square root of x plus 4 times 2 is positive 2 square roots of x plus 4. Negative 2 times the square root of x plus 4 is negative 2 square roots of x plus 4. Those will combine and give you 0. And then negative 2 times 2 is negative 4. Oh my gosh, look at that. This whole crazy bit out here, then you multiply them together, is going to simplify to just give you x. Now I'm not going to distribute in the denominator, and you'll see why in just a second. You've got x times the square root of x plus 4 plus 2. Like we said earlier, the plus 4 and the minus 4 cancel out, or add up to 0. You have an x as a factor in the numerator and x as a factor in the denominator. Common factors can cancel out. And now you have the limit as x approaches 0 of 1 over square root of x plus 4 plus 2. Evaluate at 0, try your direct substitution again. You're going to get 1 over the square root of 4 plus 2, which is 1/4. That's the limit. Those 3 problems that we just attacked were all done by some algebraic manipulation. These are skills that we start on in pre-calculus, and we continue into the first unit in AP Calculus. Again, I think any of these 3, they're fair game for multiple choice. I might be a little surprised to see them show up on the free response, but the point is, you never know. Let's keep going. Okay. All right, number 4, we're asked to find the limit as h approaches infinity of the natural log of 4 plus h minus the natural log of 4 all over h. Try direct substitution if you'd like. You're going to get the natural log of 4 minus the natural log of 4 over 0, which is 0 over 0. Again, the indeterminate form. Well, let's go back to the beginning. What algebra could you do here? Well, some students might think distribute the natural log through the parentheses. Unfortunately, that is not a property. It's not. Some other students might say, well, natural log minus a natural log, you can write it as the natural log of 4 plus h divided by 4. True. The key to this problem is to look at this form and recognize what's happening here. You've got limit as h approaches 0 of a function of a plus h minus f of a all over h. This form is our definition for how you find the derivative of a function at a. I would put a star next to this one. This is something that you're going to see pretty regularly. Mrs. Blakely at East End likes to call these the sneaky derivative questions. So if this has the form, double check that it does. You've got a function being evaluated at a number plus h minus your function being evaluated at that same number divided by h. Yep, that's what's going on here. Well, what's the function? Your function is the natural log of x. We need to find the derivative. Well, what's the derivative? The derivative of f is 1 over x. And then you need to evaluate that derivative at a, in this case, which is 4, and you're going to get 1/4. That is the value of your limit. This is not something I would expect any of our students to be able to do using algebraic manipulation. If you don't see that derivative form, that sneaky derivative form, I don't know what else you would do. One of the other sneaky derivatives looks like this. It's the limit as x approaches a, f of x minus f of a over x minus a. This still means find the derivative at a. I would maybe turn both of these into flashcards. They are going to show up. Okay, last one involves straight limits, and I need to make a change here. Please change this minus sign in the denominator to a plus sign. It doesn't make a huge difference, but let's try it anyway. Let's do it anyway, sorry. All right, I want to take the limit as x approaches infinity of e to the 2x plus x divided by x to the 4th plus 3x squared. Direct substitution with infinity it's not a thing. We don't do it. It doesn't make any sense. It just doesn't. So we're not going to write e to the infinity plus infinity. That's nonsense notation. But think about this. What happens to the graph of e to the 2x as x approaches infinity? The graph of e to the 2x is known to be an increasing function. It increases without bound. So as x approaches infinity, the graph of e to the 2x approaches infinity. What about the denominator? Well, this is a polynomial, a degree 4 polynomial. That means that the tails are going to be pointing up because the coefficient is positive. You're getting infinity over infinity. This is another one of the indeterminate forms. I sometimes call it indeterminate form number 2. Now, the key to solving this problem, because remember, infinity over infinity, not an answer. The key to this problem has to do with growth rates. When we look at the numerator involves an exponential. The exponential functions grow faster than anything else. The denominator is a polynomial, specifically a polynomial of degree 4. So you have an exponential in the numerator. You have a degree 4 polynomial in the denominator. Exponentials grow faster than anything else. So you have a faster growing function in the numerator being divided by a slower growing function in the denominator. The top grows faster than the bottom. What happens is that it means that your limit as x approaches infinity, ugly, of e to the 2x plus x divided by x to the 4th plus 3x squared, that actually is going to be infinity. That's that. That's your answer. There wasn't really a lot of work to be shown here. It was more of a verbal argument. The key, though, is you got infinity over infinity in the beginning, which is an indeterminate form. We then decided to classify the numerator and the denominator, exponential, divided by a degree 4 polynomial. Exponentials grow faster, polynomials grow slower. Your top grows faster than your bottom, so the whole fraction is going to approach infinity. Done. So those were 5 different ways we could go about evaluating limits. There are more, but those are really the common ones. Now, what we're going to wrap up this video with is something called L'Hopital's rule. I love L'Hopital's rule. Students love L'Hopital's rule. L'Hopital's rule is only, warning here, only to be used with an indeterminate form. If you are evaluating a limit and you get an indeterminate form, which for us in the calculus AB world is 0 over 0 or infinity over infinity. There are other indeterminate forms, but that's left for the calculus BC students to work with. If you have an indeterminate form, L'Hopital's rule says that the limit as x approaches c of f of x over g of x will be equal to the exact same value as the limit as x approaches c of the derivative of f divided by the derivative of g. Let's look at a couple of examples, and we're going to snap to this, and life's going to get really good. Okay, try taking the limit as x approaches negative 1 of 2x squared minus 2 over x plus 1. You get 2 times if we just try direct substitution, you're going to get 0 over 0. That's an indeterminate form. Indeterminate form, which means L'Hopital's rule applies. Now here's the thing. The College Board in the last year or two, they have gotten very picky about your justification to use L'Hopital's rule. What you have to do, this is not my decision, this is theirs. You actually have to break up the numerator and the denominator. You have to show them that you are looking at both limits separately. The top limit is 0, the bottom limit is 0. Because of this, L'Hopital applies. Now, if I use L'Hopital's rule, L'Hopital says take the limit as x approaches negative 1 of the derivative of the top divided by the derivative of the bottom. What's the derivative of the top? 4x. What's the derivative of the bottom? 1. Take the limit as x approaches negative 1, you're going to get 4 times negative 1 over 1, which is negative 4. That's your limit. That's the final answer. We tried direct substitution. That didn't work. We wanted to use L'Hopital, but to use L'Hopital, you have to evaluate the limits of the numerator and the denominator separately. Then that says L'Hopital applies. Take the derivative of the numerator, take the derivative of the denominator, and if you get something that is not an indeterminate form, that's your final answer. Okay, let's wrap up these last two then. Okay, limit as x approaches 7 of the square root of x plus 2 minus 3 over x minus 7. A quick direct substitution, you're going to get 7 square root of 7 plus 2 minus 3 over 7 minus 7. That's 0 over 0. I know you want to jump to L'Hopital as soon as you see 0 over 0. Me too! Me too! The problem though is if we're on the free response, you're going to have to show me and the College Board that you evaluated the numerator and the denominator separately. Limit as x approaches 2, square root of x plus 2 minus 3. You get square root of 9 minus 3, which is 3 minus 3, which is 0. Limit as x approaches 7 of x minus 7 is 0. Aha! L'Hopital applies. We now take the limit as x approaches 7, the derivative of the numerator divided by the derivative of the denominator. This isn't quotient rule. Derivative of the square root of x plus 2 is 1 over 2 square roots of x plus 2 times 1 from the chain rule, minus 0. In the denominator, 1. Let me scoot this up a little bit. Take the limit as x approaches 7, and you're going to get 1 over 2 times square root of 7 plus 2 times 1 minus 0 over 1. 7 plus 2 is 9, square root of 9 is 3. 2 times 3 is 6. I think you get a final answer of 1/6. Not too bad. Again, you tried direct substitution. You got an indeterminate form. So now we're going to evaluate both parts separately. They're both equal to 0. L'Hopital applies. Derivative of the numerator divided by derivative of the denominator, and you get a number that's not an indeterminate form. Done. All right, friends, one last one. Number 3. Limit as x approaches negative infinity of x squared divided by e to the negative x. Well, what happens as x approaches negative infinity on the graph of y equals x squared? That's right, you get infinity. What happens as x approaches negative infinity on the graph of e to the negative x? Also infinity. Now, if you know your relative growth rates, which one grows faster? You have a degree 2 polynomial in the numerator. You have an exponential in the denominator. The slower growing one is in the numerator. The faster growing function is in the denominator. Your bottom grows faster than your numerator. Your limit is 0. That is the answer. Now let's see if we had actually used L'Hopital. Well, why can we use L'Hopital? We have an indeterminate form. Of course, if we're going to really do this, you have to do limit as x approaches negative infinity of the numerator and the denominator separately. They both approach infinity, so L'Hopital applies. So we take the limit as x approaches negative infinity, derivative of the numerator, 2x, derivative of the denominator, derivative of e to the negative x is negative e to the negative x. What happens as x approaches negative infinity? In the numerator, you get negative infinity. In the denominator, as x approaches negative infinity, e to the negative x approaches positive infinity. With that negative in front, the top approaches negative infinity, the bottom approaches negative infinity. Indeterminate form, You have to use L'Hopital. Oh my God. That means you have to find limit as x approaches negative infinity of 2x. We know that's negative infinity. You take the limit as x approaches negative infinity of negative e to the negative x. We know that's negative infinity. So L'Hopital applies. There's no limit to the number of times you use L'Hopital. You just need to be careful that you're only using L'Hopital when you have an indeterminate form. Take the limit as x approaches negative infinity of the derivative of the numerator, 2, divided by the derivative of the denominator, e to the negative x. Limit as x approaches negative infinity, we get 2 over what happens here. X approaches negative infinity. The graph of e to the negative x would approach positive infinity. Numerator gets close to 2. Denominator gets bigger and bigger and bigger. Whole fractions equal to 0. Done. Ta-da! That was a really sad smiley face. Anyway, my friends, that's it. There's a whole lot more we could do with limits. We could look at graphs. We could look at data tables. We could build your calculator skills. But my purpose in this video was to focus on algebraic techniques for evaluating limits, and then to use L'Hopital's rule. Anyway, that is it. I hope you found this video helpful, and talk to you later.